Being hunted by a lion is likely among the scariest things any animal can experience. The only thing worse is being hunted by a group of them. Cats the world over are the scariest predators in their ecological niches, due to their stealthy hunting, their lethal claws, and a ridiculous bite force. Most cats, and even some small cats, are considered to be the apex predators where they live. I'm even sometimes scared of my own cat. And the big cats, members of the group Panthera, are especially capable of taking down large prey with a single attack. Lions may not be the biggest cat, but they are the only social big cat. We're so familiar with the concept of lions living in prides and hunting in groups that we forget that this is completely unheard of in the world of cats. Every other cat is a lone wolf, or rather an independent maverick, but not lions. They stick together and weaponize their alliances. And this adaptation launches them to the next level when it comes to lethality. Their strength in numbers of course comes in the form of multiplied raw power. Each lion weighs between 280 and 420 pounds, or 130 to 190 kilograms, and they hunt in groups of 3 to 8 or even more. This provides enough deadly force to take down a 13,000-pound or 5,900 kilogram elephant. But it's not just raw power that makes these big cats the most devastating. It's their intelligence. Lions can solve puzzles that tigers and leopards can't, and they're able to learn by watching others, a skill that is exceedingly rare in the animal kingdom. And with this unmatched intelligence, they coordinate their hunts with military precision. No zebra, elephant, or warthog is safe when lions lurk nearby. And as much as we would like to think humans are not on the menu, history tells us otherwise. In one case, a single pair of lions killed and consumed over 100 people in a 10-month period. Man-eating behavior in lions is not common, but sometimes there are factors that flip the switch and make humans an irresistible target. The history of lions hunting humans and our general cultural obsession with them stretches continents and millennia, with lions only going extinct in Europe a few thousand years ago. So just how smart are lions? And if being social is so effective, why are they the only cat to ever evolve to live this way? How do they coordinate their hunts? And what leads to nightmarish man-eating behavior? The lion, or Panthera leo, is a large cat of the genus Panthera, currently native to sub-Saharan Africa and a tiny part of India. But their historical range was much, much wider. Recent fossil discoveries make scientists now think it extended into parts of Europe, from Greece all the way up to Hungary and even Ukraine, perhaps until as recently as 300 BC. There, they would have eaten things like wild boar, deer, livestock, and even people. Today, the Panthera genus of cats includes 5 living species: the tiger, lion, jaguar, leopard, and snow leopard, and 2 extinct species, the American lion and the cave lion. The cave lion may have been the largest big cat to have ever existed. They were nearly 4 feet tall at the shoulder, and from the tip of their nose to the end of their back, excluding their tail, they were nearly 7 feet, or 2.1 meters long. These lions lived all over Eurasia, and cave paintings in France dating back 17,000 years clearly show humans were thinking about, and were probably worried about, these giant maneless cave lions. American lions evolved from cave lions that crossed the Bering Land Bridge into North America, and were also bigger than modern lions. Cave lions went extinct around 14,000 years ago, and American lions went extinct around 10,000 years ago. Today, modern lions are the second biggest of the big cats after tigers. And while you might guess that the Panthera genus is defined by their size, since all of these big cats are enormous, that's not quite the case. Cougars, or mountain lions, or pumas, whatever you want to call them, are often bigger than leopards, and cheetahs are often bigger than snow leopards. But cougars and cheetahs are not in the Panthera group, despite being objectively big cats. What actually defines cats in the Panthera genus is their ability to roar. All Panthera species have a partially flexible hyoid bone, whereas other cats have completely rigid hyoid bones. This, along with larger vocal folds, allows the big cats to roar. Much to their dismay, the other cats can't roar like this. But there is one exception to this roaring rule. Snow leopards actually can't roar even though they are in the Panthera genus and have a flexible hyoid. Scientists still classify them as Panthera because they're more closely related to the other roaring cats. It's likely they lost the ability to roar due to the lack of other necessary vocal cord adaptations. And of all of the big cats, the lion has the loudest roar. It can reach 114 decibels, which is just below where it starts to hurt your ears for humans, and can be heard 5 miles or 8 kilometers away. Roars are loud, low-pitched vocalizations which can last up to a minute. They start with soft introductory moans, then a series of full-throated roars, and then a final sequence of grunts. In a group of lions, roaring together strengthens social bonds. And even from a great distance, lions can identify the sex and even individual identity of a roaring lion. But male lions roar largely to establish and defend their territory, warning off other lions that this area is theirs. And this roar, paired with the lion's mane, is truly iconic. The conspicuous golden crown gives them an aura of royalty and power that humanity has been obsessed with for thousands of years. But what is the purpose of a mane really? The famous features of other big cats, like a tiger's stripes, are meant to camouflage it. A lion's mane, on the other hand, is striking, salient. It wants to be seen. For a long time, scientists like Charles Darwin believed that the mane was likely there to protect the lion's neck from a rival lion's teeth and claws. But scientists more recently studied male lion aggression and found that when they fight, they mostly target each other's legs and hips. Plus, when a male lion gets sick or injured, his mane has a tendency to fall out, which would render him completely vulnerable to death if the mane was indeed a shield. Scientists realized that instead, the mane serves as a visual display to avoid fights altogether. A darker, bigger mane indicates to other males that they are well fed and have a ton of testosterone. Plus, the lady lions think it looks really cool too, and choose to mate with males with bigger manes. But these manes come at a cost. Having a dark, huge mane like this is like wearing a heavy winter coat on the African savanna, where temperatures can soar. It's such a heavy, hot burden that male lions with big manes sometimes stop eating in the hotter months, since large meals increase heat load. Even on the savanna, you pay the price for fashion sometimes. Because of the sweltering heat of the savanna, lions sleep a lot during the day to conserve energy, lounging in the shade as much as possible. It's at night when a pride of lions really comes alive. Lions do most of their hunting cloaked in darkness. This is possible because of their incredible night vision. Lions have a 25-to-1 ratio of rod cells to cone cells. Humans have a ratio of just 4-to-1. Rods are used to detect contrast and movement, and nocturnal animals have an abundance of them, whereas cones discern detail but require a well-lit environment. Lion eyes are also characterized by the tapetum lucidum. This is a reflective layer of cells behind the retina, which acts as a mirror and gives the rod cells a second chance to absorb light waves. And when subjected to bright light, the oval pupils of a lion contract to a pinpoint, rather than a slit like in smaller cats. Whereas vertical slitted eyes are better for smaller, usually nocturnal predators to ambush their prey, circular pupils are better for actively chasing down prey. And while it's clear that lions need a ton of brute strength to take down large prey, there's something else required for them to hunt successfully: explosive acceleration. A single lion hunts by first stalking its prey, often hiding in tall grass. While nighttime is preferred for hunting, lions will still hunt in the day if the opportunity arises. Then, as the lion closes in on its prey, it launches the ultimate attack, quickly accelerating from 0 to 50 miles per hour or 80 kilometers per hour, and sometimes leaping as far as 36 feet or 11 meters. The lion quickly closes in on its prey. To achieve such acceleration requires muscle fibers that can generate enormous amounts of force in very little time. Researchers investigated these muscle fibers and found that most lion muscle appeared white in color with very little red coloration. This indicates that the muscle contains a large proportion of fast-twitch fibers. And more specifically, they found that lion muscle tissue is composed predominantly of type 2X fibers. Type 2X are the fastest type of fast-twitch muscle fibers in the animal kingdom, and are abundant in lions, cheetahs, and caracals. Humans have a very small percentage of type 2X muscle fibers, around 5% or less of our total muscle fibers. Lions have between 50 and 80% of these types of fibers. Humans have other fast-twitch muscle fibers as well, but these are mostly type 2A fibers, which don't contract nearly as fast. And interestingly, lions and zebras seem to be locked in an evolutionary arms race of speed and acceleration. The speed and acceleration capabilities of both animals are remarkably similar, but the lion comes out just a little bit on top. The predator needs to be more athletic than its prey to have any hope of a viable success rate. Once the lion makes contact with its prey, its teeth and claws pierce through its flesh. A lion has 30 teeth. Its 4 enormous canines are used to hold its prey, kill it, and tear it apart. 4 cheek teeth called carnassial teeth are used for cutting through tough skin and tendons. A lion's bite force is around 650 to 1,000 psi and can be strong enough to kill large prey in a single bite. A lone lion is a terrifying force, but when lions combine their power and strategically coordinate their hunts, they can take down almost any animal. Female lions do almost all of the hunting in groups of lions, and despite having no social hierarchy, their hunts are sometimes masterfully organized. But before we get too excited, it's important to note that cooperation in hunting shows up in many ways across the animal kingdom, and sometimes it seems like it happens almost on accident. Bats passively cooperate by hunting close to other bats so they can eavesdrop on each other's sonar. And social spiders sometimes work together to take down prey that would be too large for a single spider, which is possible because all individual spiders are attracted to the prey simultaneously by the vibrations of their shared web. So how can scientists be sure that the lions are actually being strategic in their hunts and not just ganging up on nearby prey at the same time? To find out, scientists in one study observed 486 group hunts, and their first clue to the level of cooperation appeared before the hunting even began. When a lioness spotted a prey animal, she would look at the prey, then look back at her peers to begin to get their attention. Then she would use grunts or body language until all nearby lionesses were looking in the direction of the prey. This shows an awareness that she wants and probably needs help. And then scientists witnessed something extraordinary. They noticed that lionesses don't just all mob the prey animal, running at it all together. Instead, they hunt in specific formations, where each lioness has a specific role. When stalking prey, some lionesses act as wings and circle the prey, and others act as centers and wait for the prey to move toward them. The lionesses that occupy the wing roles are the ones that initiate an attack on the prey, while the lionesses in the center roles don't move very much, and instead wait and capture the prey as it runs away from the other lionesses right towards them. The fact that lionesses fall into these specific roles to catch prey is incredible enough, but what's more interesting is that each lion in a given pride repeatedly occupies the same position. The x-axis on the graph here corresponds to the different positions. The outer letters are the wings, and the center letters are the centers. So this lion, lion number 27, had a clear inclination to act as a center, whereas lion 34 had a clear inclination to act as a left-sided wing. Numbers 46 and 49 preferred the right-sided wing position, and so on. Every lion did a certain type of role more often than the others. And the scientists found that the hunts where the lionesses occupied their preferred positions had the highest probability of success. And for large, dangerous, or difficult to catch prey, the payoff here, even if it does mean they have to share the prize, is still very much worth it. When lionesses work together, they have a much higher success rate, and each lion ends up with far more food. When a single lioness chases and hunts a fleet-footed prey like a springbok, she has a success rate of just 2.3%, whereas cooperative hunts have a high success rate of up to 30%, which increases with hunting group size. But how do the lions know which positions to take? How do they know which role suits them best? Some of this self-sorting might come down to size and age. Center lionesses seem to be somewhat older, heavier, and larger than wings. Their size and experience may make them more capable of being the ones to ultimately take down the prey. But there is still some debate about whether the lions are consciously making these decisions. I don't know if scientists have been able to, or could ever prove, what level of planning and self-awareness each lioness has of her own strengths and weaknesses. Dr. Craig Packer, professor at the University of Minnesota and director of the Lion Research Center, has a different take on lion group hunting. He thinks highly coordinated group hunting behavior could be heavily influenced by what prey is being targeted and where it's happening.
In that particular study in Namibia, the prey always seemed to be the same species, and they were hunting springbok, which is a very fast-footed, fairly small prey. And the thing about that is that if it's a small prey, you need to catch a lot of them over and over and over again. And it was in fairly open habitat, and so the landscape was fairly similar from one hunt to the next. And so I can imagine that those are circumstances that would allow them to behave in a fairly stereotypical way. Right, time to hunt again. I go to the left. That's just what I do.
So in a sense, they get a chance to practice a lot and find out what works best. But in other situations, Dr. Packer has observed totally different behavior. Lions don't necessarily coordinate their hunts when the prey or the terrain is variable. And sometimes they don't hunt together at all.
Now, I do have another project going on in Botswana right now that's fairly similar to that study in Namibia in terms of the habitat, although they don't rely so much on the one species of springbok. But what we see in the lions are only barely social down there. So there we do see a lot of lions hunting alone.
So this leaves a big question. Why are some lions more social than others? And in fact, why are some lions social at all, when no other cat on Earth lives and hunts in social groups? For a long time, it was actually a pretty big mystery.
When I first started working on the lions in the Serengeti, I think most people thought that lions were social because of the need to hunt cooperatively. But the question was, are they hunting in a way that makes them social, or were they social already?
But like Dr. Packer just said, lions don't always hunt cooperatively, especially if the prey is easy to catch, like something slow, injured, or simply less formidable. So for this reason, Dr. Packer and his team don't think hunting is the evolutionary reason behind lion sociality. Next on the list of reasons for why lion sociality evolved could be the fact that females of the pride raise their cubs together in what is called a creche.
Is that something that has led to their sociality, the advantages of raising cubs together, or is it that they're already together and so therefore they can pull their cubs? So cub rearing in lions can be quite striking in that you can watch a cub and it will nurse from one female and then wander over to another female and then nurse from that female as well. But then it turns out that the cubs are basically parasitizing the other mothers. It's mostly a matter of cubs waiting till the females have fallen asleep and then sneaking over and nursing from them when they're not paying much attention. And so that's not a huge advantage.
But there is another very important reason lions rear their cubs together.
Now, the other thing that we see about that cub rearing is that the females actually are not together in order to nurse each other's young, so much as they are together to protect their cubs against incursions by outside males who will kill the unweaned cubs and the dependent cubs so as to replace those step cubs with their biological offspring.
Needing to protect your cubs from infanticide could be a strong enough evolutionary pressure to adapt to live in groups. 3 or 4 female lions can easily take on one male.
But that's not the reason why lions are social, because we know that cougars, tigers, leopards, just about any solitary cat you can think of, they're infanticidal too.
So the answer to the lion's sociality mystery is not hunting, it's not cub rearing, it's not protection against infanticide. But there's one more reason that's still on the table.
And so the last one that we knew was important, but was much harder to get naturalistic observations because this mostly happens at night, is their defense of a territory, which they do as a group. In the few observations we did have of real live incursions of strangers inside a group's territory, what you see there are far more developed forms of cooperation than when they're hunting. So if a strange male wanders into the territory of a resident coalition of males, the 3 or 4 males will systematically surround the stranger and they'll attack him from his backside. The invader always has his back turned towards somebody.
Territory defense. This seems to be the driving factor for organized cooperation and could have provided the evolutionary pressure to become social. In fact, it seems to be such an important part of the lives of lions that it even allowed lions to evolve the ability to count.
The lion's roar is their way of telling their neighbors this space is occupied. And so we did a number of experiments where we found out that the lions evaluate the number of roaring lions in terms of how many lions are present in the group that's listening to the number of potential intruders. And they would go forward when they safely outnumbered the intruders. This is one of the first times anybody's ever shown any animal species that they can count, and they behave very precisely in those circumstances. So we knew that group territoriality was a really important situation for them.
But what about lion territory is so different than any other big cat's territory? What's so special about it that the lions had to evolve in an entirely different manner to all other cats?
So if you think about the landscape, just about anywhere you are, you've got riverbeds, you've got rocky outcrops, you've got patches of forest or whatever. And if you look at the landscape for the lion, compare that to the habitats that other cat species live in, it's far more uneven. There's certain spots on that landscape where the lions live that are really super valuable. And so you have this wide expanse of plains in the savanna, and you have relatively few sources of water, particularly along riverbeds. These stretches are the most valued places because these are where the lions can get a drink. These are the areas where the prey also come to drink. And there's certain spots, too, where the prey are easier to catch and where the prey are more reliably going to come. And so you've got food, you've got water, and this is also the places where you've got trees, and so there's shelter, so they can hide their cubs. And so you have these small patches of highly desirable real estate that can be controlled by a group.
And the bigger the group, the better the real estate. And the better the real estate, the more descendants the lions are able to leave.
And it's sort of tipped them over the edge into sociality.
This evolutionary story is completely unique. But it still leaves me wondering about the other big cats. Don't tigers need food, water, and shelter too? Don't they need a good habitat to survive? What about leopards that live in the very same regions as lions? Why didn't they evolve to become social too? For cats like tigers, they didn't evolve to become social because they live in much more homogeneous habitats.
And the leopards, but there's a problem for the leopard, and it's called the lion. The lions hate leopards, and they hate leopards particularly because leopards are predators of lion cubs, and they're also competitors for food. And so when lions see leopards, they'll go out of their way to try to kill them. And so it's very hard for them to have the same kind of general lifestyle around these hot spots that the lions do.
So it's almost like the leopard's evolution might have been impacted by the lion's evolution.
Yeah, that's right. I mean, if the lion were to go extinct and the leopard were to stick around, then they might eventually come to the same sort of thing, yes.
The evolutionary path to sociality in lions was an unusual one that required a specific recipe of elements, their own physical dominance, the patchwork of geography of the African landscape, and the ecology of all of the other animals around them. And from this pathway, lions got to step foot on yet another, a pathway towards increased intelligence. The social intelligence hypothesis is the theory that suggests that complex cognition and larger brains evolved in response to the challenges of social complexity. So scientists think that the lions are smart because they are social. One study done in 2015 put this idea to the test. They compared two social animals, lions and spotted hyenas, to two non-social cats, tigers and leopards. Hyenas are not cats, but live in large social groups in the same ecosystem as lions, so they're a good comparison animal. Would the social animals, the lions and hyenas, perform better at cognitive tests than the non-social ones? To find out, the scientists presented each animal with a puzzle box. The box had a spring-loaded hinge door, and a spring latch held the door closed. The animals opened the door by grasping a pole attached to the latch and pulling away from the box at a 180-degree angle. Pulling at an angle other than 180 did not engage the latch. Scientists designed this box to test the animal's innovation. Animals depend on innovation to adapt to changing environments, exploit novel resources, or expand their niche. And innovation is associated with cognitive complexity. Each type of animal had some success with the task, but overall, the study found that lions and hyenas greatly outperformed the leopards and tigers. So this supports the idea that cognition is linked with an animal's sociality, which explains why lions are the smartest of all of the cats. And their intelligence goes further than just solving simple puzzle boxes. Later experiments showed that not only can they solve a novel problem, but they can remember techniques that they used in future trials even months later. In this 2016 experiment, researchers tested lion cognition using a suspended puzzle box. Lions would need to pull a rope downward to engage a latch and open the trap door to release a food reward to the ground. The lions quite easily solved the task, but also remembered how to solve a similar task 7 months later. And what's more, when lions who repeatedly failed the task watched a lion successfully complete it, 4 out of 5 of those lions achieved success. This implies social facilitation in problem solving, which shows yet another layer of a lion's cognitive abilities. And scientists studying the brains of big cats found something else incredible. They compared the brain volumes of lions, leopards, cheetahs, and cougars, and found that the female lion anterior cerebrums, the area containing the frontal cortex, was larger than the other felid species and also larger than males of their own species. This could be a reflection of the greater social complexity in a female lion's world. To me, this heightened intelligence makes lions the most fascinating of all of the big cats. However, it also makes them the most terrifying. They can coordinate hunts on large and dangerous prey animals, but also on us. In March of 1898, construction began on a railway bridge over the Savo River in Kenya as part of a massive railway project linking Uganda with the Indian Ocean. Several thousand workers camped over an 8-mile or 13-kilometer stretch to build this section of railway. But what started off as run-of-the-mill backbreaking labor soon became an unimaginable nightmare. The 9-month period of sheer terror began when men would crawl into their tents at night to sleep, only for their slumber to be pierced by the screams of someone being dragged into the bush to be devoured. It became an almost nightly occurrence. The men quickly realized that this was the work of lions, 2 maneless male lions to be precise. John Patterson, the engineer in charge of the project, wrote, I have never experienced anything more nerve-shaking than to hear the deep roars of these dreadful monsters growing gradually nearer and nearer, and to know that someone or other of us was doomed before dawn. The workers tried to make a shield from the attacks with campfires and thorn fences, but were unsuccessful. The lions could jump over these deterrents. Hundreds of workers fled, and construction on the bridge was halted. Months of attempts to kill the lions failed. The lions outsmarted the people at every turn. Eventually, after many attempted traps, bait, and night watches, the lions were killed. Their bodies are now displayed at the Field Museum in Chicago. It's debated how many people were killed before the Reign of Terror was ended, but estimates are up to 135 people, between the railway camps and local villages. A recent isotope analysis that looked for human-specific isotopes in the lion's remains thinks that the number was more like 72, but still, that's so many people. For the humans involved, this was obviously terrifying, but scientifically, it's also baffling. Lions don't often prey on humans, not because we're better than zebras or something, but because we're a high-risk, low-yield food. But sometimes there's a perfect storm of conditions that tips the needle that puts humans on the menu. And virtually all of the recognized conditions for man-eating outbreaks to occur were in effect at Tsavo in the 1890s. The first predictor of man-eating behavior is a lack of other suitable prey. The area was in the middle of a 2-year drought, which was reducing local wildlife populations. On top of this, a few years prior to the attacks, rinderpest had been introduced to Africa. This is also known as cattle plague, and is a highly contagious viral disease that killed thousands of cattle and buffalo, the primary prey of the Tsavo lions. The next predictor is the health of the lions themselves. If they're sick or injured, they might not be able to hunt their normal prey. And by examining the skeletons of the 2 lions, scientists realized that this was definitely the case. In this picture, you can see that one of the lions had a fractured lower right canine, and in this picture, you can see the other lion's fractured upper left carnassial with a double pulp exposure. They probably got these debilitating injuries from taking down large prey, and these injuries would have made subsequent hunts of such large prey painful, risky, or maybe even impossible. Humans would have been a simple and fairly easy solution to their need for prey, and much easier to subdue than a zebra. So while humans are still a risky prey item because of our weapons, the lions might have had no other choice. And it turns out that the 2 man-eating lions of Tsavo were not the only ones. A recent historical review of the literature shows that this behavior was well established in the vicinity of the railway bridge well before the 2 infamous lions appeared, and continued well after they were killed. This implies that eating humans may have become a local behavioral tradition among the local lions. Intelligence in top carnivores is among the most interesting things to have ever evolved on this earth, but it can also be the scariest. It's no wonder that humans have been haunted and enchanted by this species for thousands of years. We've gone from cave paintings to now in-depth scientific experiments and field research of lions, which is an activity that many of us can only dream of doing. The scientists who do it get to witness the most thrilling lion behavior, while also getting to understand the personalities of each individual lion, and even get to see how prides evolve and change over the years. In my hour-long conversation with Dr. Craig Packer, he told me some of the most incredible stories about what it's like to observe lions year after year, including some absolutely heart-melting stories about downtrodden, lonely male lions who eventually find friendship, stories about how lions end up hanging out under their research vehicle, and his perspective on the best way to conserve and protect these incredible creatures. To watch the full interview, head over to Nebula, where it's located on the Real Science page as a Field Notes episode. Nebula is the streaming platform we built for exactly this reason, to create extra and original content that doesn't necessarily fit on YouTube. On my Nebula page, you can find extended interviews like this, and also standalone original series, like Becoming Human and Archaeology Quest. The first is a high production value, in-depth series about the incredible steps of human evolution. The second is an in-person game series, where I compete in Paleolithic tasks to see if I could have survived 10,000 years ago. There are hundreds of creators on Nebula and so many original shows like this that you can't find anywhere else. And right now for the holiday period, we're offering gift cards to Nebula for you to give to your friends or family members. This is a great last-minute gift idea. It's a totally digital, instant gift that will give your friends and family so much original content without having to worry about yet another subscription. 1 year subscription is only $36. Or to give your friend or family member access to everything Nebula will ever have to offer, you can gift a lifetime subscription for $300. This is a great gift for the people who lament having to pay for so many subscription services to get quality content these days. With this option, you can buy once and never pay again. Lifetime subscriptions, whether it's for yourself or as a gift, help fund original series. And I know there are thousands of you who got access to Nebula earlier through an old bundle deal, and we want to make it easier to come sign up directly, so we're offering a year of Nebula for only $30. So if you've ever had access to Nebula before and want to keep supporting what we do, signing up directly is the best way to do so. By becoming a Nebula subscriber, you get to watch all of the experimental and new ideas that are being made by your favorite creators all the time. There are so many amazing original shows and films on Nebula, like Tom Nicholas's new feature-length Boomers documentary, a documentary about the rise of the gerontocracy and the questionable legacy of the baby boomers. Or there's Neo's Underexposure series that looks at the shadowy and mysterious aspects of many world events. So for less than the price of a cup of coffee per month, you can get access to all of Nebula's originals, along with the Real Science full catalog without any ads. You can also easily download videos to watch on the go, all for just $3 a month. So go to nebula.tv/realscience or click the link in the description to get 40% off a yearly subscription for the incredibly low price of $3 a month.